A flashing or pulsating LED can only convey so much information. So the next step is getting a value out of the microcontroller. As long as the microcontroller has at a minimum a UART module and a pin I can at least share, I usually will send the data to a serial port on a computer. Sometimes just need to monitor what is going on with a variable. As it turns out, the tinyAVR 0 series has what looks to be like a very nice universal synchronous asynchronous receiver transmitter module, and I have all the pins available, so let's monitor some data. I like this USB to serial adapter. It has a switchable 3.3 volt or 5 volt TTL level connections on it, which is the connections I always use, and it's held up very well. Been very pleased with the quality of it. I'll just be connecting the test board's TX line to the adapter's RX input, and I'll hook up the Pickit 5 programmer, and that should do it for the hardware connections. The plan is to send the PWM value to the computer to see what's going on. I'll start up the MCC, going to use it to configure the USART. Under the device resources, I'll scroll down to the peripherals section, and then select and add the USART 0 module. I will leave the name at the default. I will enable the interrupt-driven checkbox. Now I'm not using the receiver, so I'll set the RX buffer size to its minimum. I'll leave the TX buffer at the default of 8. RAM is really tiny in this thing, so have to conserve it. I normally default to 115,200 for the baud rate, but with a 2.5 MHz clock, that is a bit more error than I would like. Next step down. That's still a bit more than I would like. Would probably work fine. Okay, 38,400 is less than 0.2% off. That plus the internal oscillator should put me at less than 2.5% off of the 38,400 baud rate. Shouldn't have any problem with that. Turn off the receiver. I'll have to see if that saves any code. And the frame defaults to 8N1, which is just what I want. I'll turn off the receive interrupt enable. Now have some pin warnings to deal with. I don't want to output the XDIR signal. Can't seem to turn it off. I was using PA6 and PA7 for test outputs. I'll just remove both of those. I don't want an input to be used, but again can't seem to turn it off. Can't seem to turn any of them off. That's a bit strange. An info message to set the TX pin to start high, the idle state. Okay, I can disable the output for the XDIR pin on the pin module page. TX pin is not even set for output. I'll set it as an output and to start high. It's like it wants to operate in half duplex mode. I'll generate the code and take a look at the files it created. First, the header file. Well, disabling the receiver didn't remove any of the receive functions. So the write function will block until room for another byte. Let me look at the .c file. So it has its own circular buffers. Looks like it's set up to work just like it is. As long as I don't send over 8 bytes at a time, it shouldn't block, so that looks pretty nice. I'll include the USART 0 header. Test 1 and Test 2 don't exist anymore, so I'll comment them out. Let me see if it will compile without any errors. Yep, that's a good sign. So going to need a bit of code to send the data to the serial module, as I will send it as ASCII characters. The receiving end is expecting ASCII text, so that's what I'll send it, just to make life easier. Can send no more than 8 bytes at one time, and with a 38K baud rate, say no more than 3 bytes a millisecond. So I'll just send the data every 20 milliseconds. Now I need to convert the unsigned integer to characters. We'll need a buffer to hold the characters, one that persists outside the function call and is accessible to other functions. This routine will use modulus and division, and this microcontroller doesn't have a division instruction, so I expect this to consume a large amount of time. I'll put a delay between the conversion and sending the data. Not really needed. If the conversion routine takes more than a millisecond, it will just delay the mstick routine. Should just need the write function, send the characters, and then need to send the carriage return code, hex D. Okay, it builds, using up the 4K bytes pretty quick. Program the chip and let's see what I get. I'm on Linux and in a terminal window. I'll check and see what the name of the serial port is. This is a list of the TTY devices. The TTY USB 0 is the WaveShare USB to serial adapter and the one connected to the microcontroller. The TTY ACM 0 is going to be of interest a little later. The current settings for the TTY USB has its baud rate set at 9600. I'll change that to 38400. Cooked seems to work for the settings. And then I'll send the TTY USB 0 data to the standard output. I think that looks like it should. Let me slow it down some more. Even a value every 50 milliseconds is a lot to keep track of. If I was looking for a bad value, I would send the data to a file, and that way I could carefully look over all the data from the start. I'm a bit curious as to how long the modulus and division are taking, so I'm going to measure the time spent in these two routines. So I'm going to use PA7 as a test output. Seems every time I go to the pin module, the PA0 and PA7 are reset. I don't know if I have something set wrong, or it's just a bit of rough edges around the MCC support of the ATtiny 402. I'll turn off the output for PA0 again, turn on the output for PA6, and leave PA7 output turned on, and give the pin a name I can remember. And then generate the code, and I'll ignore the warnings. So let's see what we get. I'll toggle the PA7 pin around the two time-consuming lines. I'll put the scope on the PA7 signal line and see what kind of time it takes. About 40 microseconds to do both the modulus and division. Instruction clock should be around 400 nanoseconds, so around 100 instruction clocks. Not near as bad as I was expecting. So could do 5 digits and still have time to spare in the millisecond. Now about the TTY ACM0 serial port I mentioned before. That is the datastream serial port supplied by the Pickit 5. Now the ICD4 was supposed to have a datastream port. It lists pins for it in the user manual, but I never saw a serial port pop up when it was plugged in. And the serial pins were kinda hard to access when using the 6-lead programming cables. I had my own serial interface, so I never did look into it anymore. But the Pickit 5 does have a serial port pop up when it's plugged in. And the pins are easy to access. Well, all I had to do was make myself a new cable. And as a bonus, I would expect the signal levels to track what the VCC target voltage is set at. So let's see if it works. So the program should stay the same, just need to swap out the WaveShare serial adapter for the Pickit 5 serial data lines. Again, just using the RX line, pin 7 on the Pickit 5, to connect to the test board's TX line. I'll set the TTY ACM0 to the same settings I set the WaveShare serial port, and then send it to the terminal. Well, that is nice. That is going to be so convenient. I'm really starting to like this Pickit 5, a lot. One of the plugins I haven't used in MPLAB X is the Data Visualizer. Think I fired it up one time to see if it could see any data port on the ICD4. Of course it didn't. There is the serial port from the Pickit 5 and can set the baud rate to 38,400. Has a terminal section at the bottom of the window. Want the source to be the Pickit 5 serial port. I want the new line to be just a carriage return. That's what I'm sending. And a play button to start it. Well, not getting a new line. Let me try some of the other settings. The new line character is under the output section of the terminal, so that may not do what I want it to do. Yeah, that doesn't seem to have any effect. Well, let me do it the proper way and send a carriage return and a line feed. Still be well under the 8-byte limit. Okay, that's what it was looking for. I don't see any way to set what it sees for a new line, and I don't see a way to save the terminal data to a file. But for just a quick look at what the data is, that works. After poking around this data visualizer a bit, it looks as if it can take in a formatted raw data. Now that would really be nice. Could surely save a bit of time and work. So let me give it a try. Right on the Pickit 5 serial port, there is a button that will pop up for a new variable streamer. I'll select that. I'll give it a name. I guess the name is just for me to reference. I'll give a name to the variable. I'm only going to have one, but there could be more. My total frame size is 4 bytes, and this variable starts at position 1 in the frame. This is what Microchip's example frame looks like, so I'll just follow that example, except with just one integer. Okay, that is the raw data in the range of the ASCII digits to the carriage return character. Let me change the output from character data to the integer value of the PWM variable. I'll comment out all of this. I'll be sending 4 bytes, so I'll set it to do it every 10 milliseconds. Start with the frame start byte, then I'll send the low order byte of the PWM value, and then the high order byte, and then the frame end byte. No macros for low and high byte? I may not be including something I should. Let me see if I remember how many parentheses to put around this. I'll do it a piece at a time. That should work out. Okay, that should send the 4 bytes every 10 milliseconds. I'll program the chip and then see what I get with the data visualizer. So if the source is the serial port, it shows the raw bytes of data coming in. I can select the PWM variable, and it adjusts the scale of the graph. That's nice. Can pause the graph and use the cursor to measure with. Looks about right, near 0 to right at 2050. Nice, the terminal will work at the same time. and can display the values in hexadecimal. And it's just displaying the PWM value. That is well done. Maybe there is a way to save the data to a file. Can select the start, end, and/or duration time. Very nice. I'll just do 2 seconds worth. That should be what, about 200 entries? Okay, get some options for the file format. That's great. I don't want scientific notation, though a couple of the data formats are floating points, so that could be very useful. Has a multi-column mode. And can turn off the timestamps. That will make the file a lot smaller. That's pretty nice. Yep, can save it to a CSV file. Well, that's all I could ask for. I could see the graph coming in very handy if looking for a variable that is way out of range, or values bouncing around when they shouldn't. Yeah, that's better than anything I've written to view my microcontroller data. Very nice. Sometimes outputting data in ASCII format is going to be preferred. Other times the raw data will work out best. The MPLAB X Data Visualizer seems to do a pretty good job at viewing either format. I think the first time I remember noticing the data visualizer was toward the end of the MPLAB X version 5 series. It may have been there for a long time. I just didn't notice it. I fired it up one time to see if it could see a data source from the ICD4. All it saw was the motherboard serial port. It really didn't dawn on me then to dig a bit deeper into what it could do with the data from a serial port. I really should have. It's a very nice addition to MPLAB X. I can see using it all the time now. And there seems to be even more to it. I've just got to take the time to read up on it. Thank you for watching.